Hello, welcome to another video in physics. In this physics problem, we are dealing with, I don't recall the number of this problem, but either way, it's one that you guys had a question on in the review, and so I just want to deal with that right now in this video. This problem deals with three forces acting on a ring in the above figure. What is the net force acting on the ring? And the ring in this figure is the circular thing on the x and y axis there. Alright, so you have three forces, the problem tells us. The first one is 64 newtons being pulled to the right, and another force in the opposite direction, 128 newtons to the left, and then a third force at an angle towards the right at 128 newtons. And that angle is 30 degrees with respect to the horizontal. I just don't have that on there yet, and you'll see why in a few minutes. So these are the three forces that are acting on my ring. And I'm going to kind of set everything off to the side because I'm looking for the net force with all those three. So just kind of picture a tug of war, if you will, with three people tugging in different directions. And I want to find out with the forces that are being applied to this ring, what is the net force? What direction is it actually going? So who's winning this tug of war? Alright, so let's set everything up to the side, up to the top, so we can have it for reference. So the first thing that I want to do is I want to deal with the x component, my horizontal. Because I noticed that in my horizontal, there are two forces that are acting in opposite directions of each other. I have 64 newtons to the right and 128 newtons to the left. So I want to call this vector A, which is my horizontal vector. So what is the net force? What is the net horizontal force in this case? And I have 128 as negative, my reference point being that the right is positive and the left is negative. It can go either way. It's all the same, really. But that's going to be my reference point. Right will be positive and left will be negative. So be that as it may there, that means my net force, my net horizontal force, because these are the only two forces that have a horizontal. Actually, the other one, the third one has a horizontal too, but it also has a y, so I'll deal with that later. So my vector for my horizontal vector is negative 64 newtons. This is important because now I'm going to be highlighting individual vectors. I have three vectors. So I want to find the x component for my horizontal, which is a sub x equals a cosine theta. So recall from previous problems that this is the general formula for finding the x component of any vector. Okay, a cosine theta, or the vector cosine theta. So in this case, our vector is negative 64 cosine, and the angle is 180 because it's only horizontal. There is no y axis to this. So that gives me x component of negative 64 newtons, which makes sense because if there were only two people playing this game, if you will, pulling on the ring, then the one on the left would be winning because it's twice the force as the one on the right. So my x component is negative 64. Now I'm going to look for a y component. Now, as I mentioned before, and as you can see in the drawing, there is no y component. There is no vertical force. All of the forces for these two are horizontal. Either way, let's work it out just so you can confirm this mathematically. So the y component is a sine theta. So it's negative 64 sine 180. And the sine for 180, as you know, is 0. So 0 times negative 64 is 0. And again, mathematically, I've confirmed what I already knew. There is no y component to these two vectors. So that was nice. I was able to deal with two vectors at once, and that's because they're opposing each other. Now this third vector, which I have highlighted in red, my yellow vector, is 128 newtons, but you'll notice that it's at an angle, and it's at 30 degrees. So I need to find the x and y component of this vector and my last vector, because then I want to add all those vectors up to get a resultant x and a resultant y. And I'll show you what that means in a second. So I can find my x component and y component simultaneously here because it uses the same parent formula that my others do. So again, anytime I'm looking for a x component or a y component, this is the formula I use. It's whatever the vector is, cosine theta for the x, and whatever the vector is, in this case vector, I called it vector b, it could be vector anything else. You know, it's a variable, so you can name it whatever you want. Vector b sine theta for the y component. So again, I know that my vector is 128, so I'm going to replace b on both of these formulas with 128, as you can see. And also the theta is the same, so both thetas will be 30 degrees. And now I can find my x component, which is 111 newtons in the x direction and 64 newtons in the y direction. Well, so I've just found the x component and the y component for all three of my vectors that are at play here. Okay, recall that the first two vectors I was able to do simultaneously, and then the third vector I found the x and y component individually. So I have my x component in the gray, and then I have my y components in the dark gray, just so you can kind of see the difference there. So I want to total them up now because I want to get the resultant vector, the resultant r vector and the resultant y vector. Because recall that my problem, if you see it at the top left, it's asking for a net force. So that means I need a resultant force of all three of those forces put together. So my total x is 47 newtons. My total y is 64 newtons. Okay, so again, my total x, resultant x is 47, resultant y is 64. So now that I have my resultant x and my resultant y vectors, I can now use Pythagorean theorem to find the actual resultant vector. Okay, and you know Pythagorean theorem very well. And this gives me a resultant vector of 79 newtons. So I'm going to lay 79 newtons off to the side because even though the problem only asks for a resultant vector, I'm going to go a step further, and you'll see why in a second. I'm going to find the theta, the angle at which this force is going at. And I think it's important because it kind of helps us to give us a better idea of what's actually happening here. So it takes the concept a step further and hopefully helping us to understand what exactly is going on. So what I'm going to do, as I mentioned, is I want to find the angle at which this resultant vector is going at. And to do this, I'm going to use my inverse tangent, which is tangent, as you know, is opposite over adjacent. So opposite would be my y component, 64, and my x component, my adjacent component, would be 47. So in my calculator, I'd want to make sure that my mode is in degrees, and then I'm going to do inverse tangent 64 over 47, and that will give me a theta of 54 degrees. And I'm going to put that off to the side. So what does this all mean? So I'm going to take my graph that was given in the problem, I'm going to centralize it so we can kind of get a good perspective of what's happening here. So let's put all this information together. I know my resultant vector is 79 newtons, but you'll notice that that doesn't really tell me what direction it's going in. So who's actually winning this tug of war? The theta gives me essentially that, it gives me that answer, because the theta is 54 degrees. Okay, so I'm going to kind of blur out my graph, and I'm going to show you that red arrow represents that resultant, that theta, 54 degrees. And this is actually to scale. This is 54 degrees in respect to the x-axis. And the yellow line behind there is actually also 30 degrees with respect to the x-axis also. All right, so this is 54 degrees theta, and it's 79 newtons. So what this tells me is that as all three of these, let's say people are pulling on the ring, And as each is pulling in his own theta and his own force, the resultant, this ring is actually moving at 79 newtons at 54 degrees with respect to the x-axis at 79 newtons. So who's winning? It looks to me that I guess you can say the yellow is winning, or maybe the yellow and blue. Now this makes sense because if you think about it, if you consider the right side of the graph, you have the yellow and the blue. The yellow is pulling at 128 newtons, the blue is pulling at 64, and then the green is counteracting both of those at 128 newtons to the left. But of course, that's not strong enough to overcome the combined x component and y component of both of these, which adds up to a resultant vector of 79 newtons at 54 degrees. So the green is being pulled back, as I said before, because of the sum of the two forces pulling to the right. Okay, well, I hope this helped, and good luck in your study.